Hello, ladies and gentlemen everywhere, math experts. I want to welcome you to the online university of Ben and Steve.
I'm Steve and he's Ben, and today we will be looking at the side splitter theorem and the triangle angle bisector theorem.
Let's start by giving some need-to-know definitions, specifically a proportion and an angle bisector. A proportion is defined as two equal ratios, and an angle bisector is a segment that divides an angle into two angles with the same measure.
Alright, so now we have the side splitter theorem. And that says that if two parallel lines, that's the symbol for parallel right there, intersect the sides of a triangle, then it divides the sides proportionally. And so I'm going to just draw a little diagram for you right here. Here's a triangle. There's our parallel lines right there. Those are the symbol for parallel if there's a little arrow on it. And these two lines are proportional to those two lines. That's what it means. Alright, so now we have the triangle angle bisector theorem is when an angle bisector intersects a side, the adjacent sides of the triangle are proportional. Here's another miniature diagram. We've got this. This is the angle bisector. This side and this side are proportional to this side and this side. That's what it is.
Problem 1. We are given a triangle with two parallel lines that intersect the sides. So, to solve this, we're going to use the side splitter theorem. We know that this is proportional to this, and this is proportional to this. So let's set up a proportion. X over 6 is equal to 5 over 10. Cross multiplication gives us 10x equals 30. X equals 3 is your answer.
Alright, so now we're on to problem number 2. So as you can see, we've got two parallel lines here, that indicates that it's going to be a side splitter. So now we have to find x and y, and we're given two sides and an angle. But if you notice here, two angles actually, my bad. Alright, you'll notice here that we have a right angle here, meaning that this is a right angle. So using that, we can deduce that this is also 45. And look at that, we got a 45, 45, 90 triangle, one of our special rights. And if you remember that, the ratio is 1 to 1 to root 2. So then this would be 4. This side right here is 4. But that means this is 4. This is 2 root 2. This is 2 root 2. And I'll explain to you why. Because see, that's this is 4. So now it's going to have to be 4 over root 2. We can't have a radical at the bottom. So we're going to multiply by root 2 over root 2. Get 4 root 2 over 2 reduces down to 2 root 2. Okay, so now we have 2 root 2 is equal to y. So we've already got half of our problem done, right? Just like that. So now we've got, it's just like solving our first problem now. We have 2 root 2 over 5 root 2 is equal to 4 over x. So now we've got 2 root 2x is equal to 20 root 2. You want to get x by itself, divide by 2 root 2. And we end up with 10. X equals 10, that's your answer. Alright, so here we're going to prove, we have a proof here. It says given AD bisects BAC, and it proved that BD over AB is equal to CD over AC. And so if you recall the definition of our triangle angle bisector theorem, when an angle bisector intersects a side, the adjacent sides of the triangle are proportional. And that's exactly what we're proving here. And as you can see, I've got all the steps written out here, so I'm just going to go over and explain what we did here. So given, that's just a given statement, AD bisects angle BAC. Now we have definition of a bisector, which proves that angle 1 is congruent to angle 2. So now, we can't really do a whole lot with just knowing this. So we're going to draw a parallel line to AD, and we're going to label it BR. And the reason why we can do this is parallel postulate, where through any given point there's one and only one parallel line to another that's parallel to another line, and that's just what we're doing, so we can draw that out perfectly fine with math logic. And now we're just extending AC to R, so that's the place where they intersect. So now we're going to use side splitter, and if you remember our definition, this is exactly what we're doing, just now it's in a proof form. And we're going to prove that AC over AR is equal to DC over DB. That's great, comes in handy. 5. So now these two are parallel. These two lines are parallel. So now using parallel to corresponding angles congruent and parallel to alternate interior angles, these are the alternate interior, 2 and 4 are the corresponding, we can get that 3 and 4 are congruent because 1 is congruent to 2, 1 is congruent to 3, 2 is congruent to 4, and 1 is congruent to 2, so 1 is therefore congruent to 4, therefore 3 is congruent to 4. Next step, we're going to use converse of ITT, because remember, must be isosceles triangle theorem says that if these two are congruent, these are equal, the converse is these are equal, therefore these are congruent. And now we've got that AR is congruent to BA. We're going to replace that, we're going to use some substitution, replacing that equation when we got the side splitter, AC over AR. We're going to replace that AR with an AB, and so now we've got AC over AB is equal to DC over DB. And now 8, last step, is our proof statement. BD over AB is equal to CD over AC, and that's because of the properties of proportions.
Hey class, it's me again. We're going to look at the triangle angle bisector theorem in this problem because as you can see we have an angle bisector which the triangle goes down, this line right here goes down to intersect this side. So we know that this side is proportional to this side and this side is proportional to this side. So we're going to set up a proportion. 12, over 9 is equal to x over 15. So all we need to do is cross multiply. So 12 times 15 equals 9x. So 15 times 12 equals 80. Cool. So 180 equals 9x. So we got to get this x alone. So 180 divided by 9 equals x, making sure x equals 20. That's your answer, class.
Alright, so now we've got problem number 4. This is, again, a triangle angle bisector theorem. So we are given AB is equal to AC. So this is an isosceles triangle. AD is equal to 8. So that means this is right here is 8. Measure of angle A is 45. And the area of the triangle ABC is 48. And we also know that it was given in the diagram that if these two were congruent, therefore this is the angle bisector. So how are we going to solve this? Well, if this 45-degree angle is going to be very important, first thing I would do is I would look for a special right triangle, but it doesn't say that this is right, nor is this 45. So it looks like we're going to have to do this the hard way and break out some trigonometry. And we're going to use tangent because remember tan is equal to opposite over adjacent, and so then the tangent of the angle, sorry about that, and now we've got tangent of 45 is equal to x over 8 because this is the opposite, that's the adjacent, and so we're going to want to solve for x here, so we're going to get tangent of 45 times 8, this is a paren, is equal to x. So now a very good trigonometric thing to know is that tangent of 45 is 1. So we just have 8 is equal to x. And we were looking for find x, y, and z. Sorry about that. So now we've already got 1/3 of our problem done. X is equal to 8. We're going to have y equals z equals. Alright, that's good. We got that. So now we have that this is also 8. And now we have this area right here. And we want to find out what y is. And remember, this is isosceles, so this is also y. And now if we have the area, as I was just mentioning, and the area of a triangle is equal to 1/2 the base times the height, if you recall correctly. So then the area of this triangle, ABC, which then is equal to 48 is equal to 1/2 the base, which we don't know, which is y. We want to find out what y is, times the height, which we know is an 8. So now we have to solve for y. So what's 48 times 2? That's 72. Oh, wait, no, that's not 72. Whoops. We're going to just do it out. It's 96. This is why you should always remember to do it out. 96 is 8y. Y is equal to 96 over 8, which y equals
Steve,
12.
correct me if I'm wrong. Since you multiplied 8 times y, does that mean this becomes 4y?
Oh, actually, we just multiplied by half because we're trying to solve for y.
Oh,
so then that's
okay.
how you get the 96.
Thank you,
Yes,
Steve.
That's a wonderful question. All right, so this one right here, this is y is equal to 12. So that means this side is 12 right here, meaning that, boom, look, we got
12.
2/3 done. 2/3. So now here we're actually going to use our theorem that we've used. So now we have to find out what this is if we want to find z. So what is 12 minus 8? We know that's 4. So BD is equal to 4. Now we have to find what z is equal to. So we have y, which is our 12 over our 8, is equal to z over 4. 48 is equal to 8z, and z is equal to 6. So z is equal to 6. That's our problem. Alright, thanks for watching. That's the end of our video.
Here are some clever math jokes. Why does the man pray before his trigonometry tests? He was looking for a sign above. What did one math book say to the other? Don't bother me. I've got problems.